All right. I hope that everybody's doing well. And okay, so this is the first day that we have. After the exam, any concerns, any questions? So let me just check the review. Okay, so any problem with that then, Brian? Yes. Any question like of the previous homework? Good afternoon, and Melinda. Okay, so I hope that everybody's doing well today. And how was the exams? Like, was it fair for all of us? All of us, like, we have 3 hours to finish the exam, and
Um,
yeah,
I guess I wasn't able to submit the work because it cleared, like, because I finished it at 2, so it cleared before I could submit it.
yeah. So that is the reason why we have to submit the exam before 2 p.m.
Like,
Actually, I checked the work I have. Seems like Barry was one of the person who did not submit the work, but I do not count your exam as zero. But I might uh let you have the opportunity to make up the exam. Is this fair? But you have to retake it. You cannot use the same questions. So when you start a new question, that should be different. Okay, so yeah, so I heard your story about the internet connections, and you have a lot of issues going on by emails. So you need to email me about the thing, and then you can retake the exam again. That will be 3 hours starting, and then you have to send me the work by 3 hours. So the later time will not be accepted. Melinda, I got you. Yeah, I got your work. Yeah, so you don't have to worry about that. Is this fair? Not another exams. Like it's basically like it has like a pack of 20 questions, and then if so for those people who did not submit the work on time, I believe I cannot check if the work was taken like 3 hours like after the exam. So I really want to make sure that people submit the work on time. There's no another exam just for the people who have not really submitted the work on times, or maybe who have not sent me the file after that.
wait, so even if we did the test, if we weren't able to submit the work for the test, we have to do it again?
Yes, you have to do it again basically because I only count the work. I can't really because I don't see how you submit the work or took the picture unless you show me the photos of the time you took the pictures, then I would count this. Is this fair?
Um, okay.
Yeah, so if you can show me like the time that you took the photos, maybe like a few minutes late, it's not a big deal, so I still count it. Yeah, I'm
Okay.
not able to resubmit it, so we can do it now. You can the homework that you can do it now. So for those people who submit the work and make sure that you I mean when you submit the work late, for instance, I need to see the time that you submit the work. Just let me know the time for the pictures, and then I will count it. Other than that, you need to retake the exam. So I never give people a zero on the exam, so I usually have to make up, or I will consider counting a second exam twice. Basically, whatever that you get on a second exam will be the grade that you receive on the third exam as well. I got
Actually,
you. I got you, Joel.
Professor,
Mm-hmm.
uh, I submitted the work at 2:03. It let me submit it. I don't know if it's gonna count it though. I don't know
Um,
if you received it.
I will check it after class for you, okay? Usually there was 2 or 3 people who haven't submitted, and I think that you already have the work in Blackboard, but I need to double check and email you after class.
I
Richard,
sum
right?
Yeah, I
Okay,
submitted it and it said give me a verification that I submitted it,
that's
but I'm not.
perfectly okay. This should be all right. If you have that verification, everything should be all right.
Okay.
Um, so my email is on the syllabus, or you can just use that email and then just email me after class. Or maybe you can email me using the announcement, but I will respond pretty late for that. I don't use that email very often, except when I contact um, with the people over using that, but this is the email that I use. And now you can also tell me what it is and what your situations are, what your issues are. I have some people who lost the connections, and meaning that you need to retake the exams, or maybe if you don't want to retake the exams, I can count the second exam twice. But for those, but it will not be fair unless you have like a very legit reason for that. Like I have lost my connection, show me the screen for that. You can't just like, well, I didn't take the exam because it was hard, I didn't study enough. So that is not like legit reasons for that. Okay, so you need to tell me your situations for the exam. And the second exam will be a lot harder compared to the third exam because of the concept and the work. Like I said earlier, chapter 5 is the most difficult chapter that we are dealing with the probability, but chapter 7 will be the most confusing chapters. The reason why it's really confusing because it's just complicated given a lot of unnecessary concept. But I will try my best to make a note and homework problem and so on and so forth. Remember, whatever that we study on the exam review might be potentially your exam question as well. So I really want you guys to be able to understand the situation that we are having uh, questions practice, but not doesn't mean that we're not going to see it again. But we still have to do a lot. And remember, if you have missings any class, and as I said earlier, that I have posted the videos and the lecture. I actually just I check everybody, so work for that. So it should be on Blackboard for all the videos and the lecture note for this. So I'm making sure that we're not going to miss any of them. Okay, so that's really important. So any concerns, any questions that we have? All right. So far so good. Now we're gonna start the new chapter. So that would be, I'm sorry, not the new chapter, but still the chapter that we have right there. So I actually posted the lecture file for chapter 6 and for chapter 5 as well, the updated one. So after chapter 6, again, there will be some like very clear and very neat files from chapter 7, 8, and 9 because those files that I prepared from last semester after the outbreak started. So it has a very good notes for that. And I will basically try my best to get people know the chapter 7, 8, and 9, and we can have a very beautiful exams. What chapter are we on? So we will be on chapter 5. We try to complete them. Again, that it still be a very long chapter for all of us. We haven't really complete chapter 5 for some reason. Okay, it's a really long chapter generally, so it's not quite easy. So let me just share my screen and you will see what it is. Okay, so I have updated a lot of work for that, and so this is chapter 5 summary, and we're going to go to the last part, which is called 5.4, and this will be the last part of chapter 5 that we're going over for today. Okay, so again, that please try to email me for any concern that you have. You need to let me know what your issues are, and if I feel like that's is a legit reason, um, and you can make up the homework. But the quizzes, I only allow you to make up the quiz number 1. For those of you who have not really made up the quiz 1, let me know. Okay, so this is what we have for chapter 5, and the chapter 5 will be the counting rule. So this one is very important for that. Okay. So the counting rule that we also call permutation in this case. So we're going to deal with three things, but we're going to focus on um, permutations and combinations. Okay, factorials, permutations, and combinations for that. Okay, so those are going to be really, really important that we're going to be dealing with for today. Okay, so this would be on the second exam questions. Again, that whatever that I cover will be on the exams, and try to take note. You cannot take note. Make sure that you're going to go back to the lecture note and figure them out. I really want you guys to be able to do it. Okay, so this is what we're going to start with one example. The concept is actually uh, from the book, from the note. I can just watch them out. So this is what we call multiplication. And what I mean by multiplication is I'm gonna give us one example and see what it is. Let's say we go to the restaurant and it has like main course, right? And that one is really important. So the main course consists of like 3 different kinds of food. On anyway, I can't take like 10 of them, but it's gonna be really long for that. So I'm gonna take 3 of my favorite food. Okay, so one I would say chicken, right? Who doesn't like chicken anyway? So that one is really tastes really good for me. And the second thing that I would like would be, um, you know, lamb, right? Lamb tastes really good for me as well. And of course, who doesn't like lamb? And the third, I would say, I do not ignore the vegetarian, but I don't really have them. And so I do apologize for that if some of you are vegetarian. But the third one would be called a seafood. Okay. And now we're gonna go to the next part would be called a drink. The drink is also consists of 3 different parts. And one that we have 3 options. The one I would say soda, right? So that's would be the simplest thing. Or drinks, a bottle of water, whatever you want to call them. So I would say soda is the easiest one that we can have. And the drink you can have for beer, right? Who doesn't like that? And so the third one would be called, let's say, after beer, we can have some juice, right? Or maybe we can have some, you know, I would say juice is legit. I like that too. And maybe some vitamin waters, whatever you want to call it, but it's not going to be something that I'm looking for. Anyhow, the last one will be called the appetizers. So this one, let's say we're going to take that appetizers, and so there will be 3 of them. So one is I would say easier. I would say one is um, you know fries. I believe is French fries or whatever the fry that you have and tastes really good too. And the second thing I would say um, salad, right? So salad for vegetarian too. I would like to have salads on my list as well. So it's really good. It's really cool. And the third choices that I can have would be bread, right? So bread would be the easiest option I can have. Who doesn't like bread in the morning, right? And it's really cool for me. And out of these choices that we're going to see, like how many combinations do we have? Like let's do it. How many combinations? I want to make this a little smaller. And how many combinations do we have? Like, do we have for a one main course, right? One drink and one appetizers. So I would say it's legit to this and one appetizers. Okay, so yeah, and that will be the question mark that we're going to have right there. 27, that's exactly the answers that I'm looking for. So we're going to have 3 choices for each one, right? And then, so let's say we're going to have one example. We do have a lot of example, but just want to make sure that we understand tree diagram when we go to chapter 6. And I would say that's pretty important as well. Yeah. So how many combinations? Yeah, no, I mean, how many ways can we form like the combinations of main course and a drink and an appetizers? So there'll be a 27 way of doing it. So let me just test out one example and see what it is. So we can have a chicken, right? Apparently soda and fry. So that'll be one combination for that. Or we can have chicken, beer, and salad, right? And we can have like lamb and soda and bread. So there's a lot of choices that we can violate. Though even though that we know the fact that they might be like a very awful choices, but it's still one combination that we can make. And like Rob said earlier, that we have like 27 way of doing it. I mean, I put more focus on understanding than the formulas for that. So we're gonna go to that real quick for this. So let's say we're gonna have like, let's make like a tree diagram, and you see what I'm doing right there. So apparently that we can have three of the main courses, and the main course that we call um, so in this case that we're going to have chicken. Let me just make this a little smaller. Chicken, and what else? So after chicken, that we're gonna have a lambs, and we're gonna have a seafood. So we can apparently have them, and this is what we call a tree diagram. So each chicken that we're going to have, like the soda that coming along, or appetizers we want to go first. It doesn't matter which one. So that one will be called soda. And after soda, that we can have choices for beer, and each option for that we're gonna have a choice for juice as well. And I believe those are pretty important. So you can literally check them for that part. So after beer, you're gonna get juice. Right? And similarly for each soda that we can have a combinations of fries, salad, and bread for the appetizer. So those are going to be like a new combination. So each soda, we're going to have fries, salad, and bread. So this is what we call a tree diagram, or we can use the multiplication rule for that. So this one that we have will be fries, and that one for soda, salad, and that one's for bread. So we can literally check that. So we can have like chicken soda fries, chicken beer fries, or chicken twist fries, or we might have chicken soda salad, chicken soda bread, or chicken's beer salad, chicken beer bread, and so on. So each branch is so we can see that those chicken that are gonna go with 9 different combinations, those lamb going to give with 9 different combinations of soda, of the drink and appetizers, and as well as the seafood. So we can literally check that we need to multiply them together. Will be 3 times 3 times
So we
3.
just multiplied
Yeah,
in this, for example, in this
mhm,
example, we just multiply 9 by 3. So
exactly.
how many combinations?
So let's say we have 5 different drinks, then we're gonna take 3 times 5 times 3. So this is what we call multiplication rule. Are we good? We need to multiply them for a certain thing if we have like a different combination of that. In other words, so that turns out to be 3 to the third power. Are we good? We have like pretty much the same thing. Okay, so that'd be 27 combinations, right? Are we good for that? So let's say I have like I have like 5 different main courses and 7 drinks and 10 appetizers. So how many combinations can we have? Like one course, one drink, and one appetizer. So we're gonna get 5 times 7 times 10. The total will be 350 combinations. Are we good? Yeah, this is what we call multiplication rules. So now this is not the main thing that we're going for. The next thing that we need to deal with will be called a factorial. Okay, so what it means by factorial, denoted by exclamation mark. Why people use this symbol, I don't know. People have been using it for many years, and I'm more like a Bible follower generally, so people use it. And after we have that, and we're gonna form it like the thing we call factorial. So very important thing that we're gonna have will be 0 factorial is 1, and also 1 factorial is also equal to 1. So that going to be really important, and we're gonna go for it. Okay, so those are, I would say, the definition. So if you go to YouTube video and then you're looking for why 0 factorial equal to 1, we're going to have like a very deep conceptual and philosophical perspective on it. and let me let you know what it is. So what is this one? What is the factorial? So factorial, let's say we're going to take 3 factorial. That will be equal to 3 times 2 times 1, and that will be equal to 6. Okay, we need to take one number, we multiply by the next number, which is one number smaller than the previous one. I mean, you have to decrease the number by 1 generally for each time that we multiply until we finish the list, which is up to 1. And similarly, I can take like 4 factorial will be equal to 4 times 3 times 2 times 1. So that will be equal to 24 way of doing it. And this is what we call the value of the factorial. So how can we compute the 5 factorial in this case? So what is the 5 factorial? I'm going to change the marker a little bit. So that will be equal to, so that will be 5 times 4 times 3 times 2 times 1. So this is what the definition looks like. I mean, this is how we're going to compute the math for that. So the total value for this will be 120, obviously, correct? And what is a 6 factorial? I want to put it right there so you can just clearly see what we're going to have right here. So 6 factorial will be equal to 6 times 5 times 4 times 3 times 2 times 1, and that will be equal to 720, right? So I can also compute the 6 factorial by taking 6 times 5 factorial, right? And a lot of people can prove 0 factorial mathematically by taking 1 factorial over 1, and we're going to get 1 as well. So it's a little bit sidetracked and a little bit hard to deal with. But generally, this is not a biggest concern. The very important thing that we're going to deal with, let's say I want to take, what is the 7
Use
factorial?
hand. Look, I'm trying to press it, not working.
I'm sorry? Okay, so let's say I want to do 7 factorial, so that would be 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on
So
and
you
so forth.
just keep going until it becomes 1, and then just multiply all the numbers.
All the number, and then each number that we multiply have to be one number smaller than the previous one, right? So every time that we multiply new numbers have to be decreased by 1. All right, so what is the factorial? So the factorial will be, what is the definition for that? The definition of the factorial will be a number of way of arranging an object into n precision. So this is actually the definition for that, into n precision. So it is the thing that we need to understand. So the number of way of arranging a certain object into like a certain, they have to be a set, like an object into n position until we finish the list, the whole list for that. So let me just give us one example and see how it looks like. Okay, so let's take a look at one example, and I will let us know what it means by factorial. So let's say we have 4 different letters. Okay, 4 letters A, B, C, D. They have to be different for sure. A, B, C, and D. Okay, so they're A, B, C, 4 letters. And we have 4 letters. Now I have to form 4 letters. So how many ways, how many combinations can we form 4 different letter words, right? 4 different letter words. So they have to be different letters, and they have to be like a 4-letter word as well. What do you think? So we're going to write them down with the 4 different letters. So let's say this is the first letters, this will be the second letters, and this will be the third letters, and this will be the last letter. Are we good? So let's assuming that we want to see how many combination can we have like these 4 letters. So I can have like A, B, C, D, I can have A, C, B, D, I can have B, A, C, D, I can have C, B, A, D, whatever it is. As long as they have to be different and coming from those 4 letters, and it's perfectly satisfy the questions. So how many options for the first one? So the first one, that for the first letter that we pick, it can be either A, B, C, D. Are we good? So it will be, so it can be A, B, right? It can be A, B, C, or D, correct? Right? Because we haven't really picked any of them. So the first letter can be either one of these options. So they have 4 choices. Are we good? Right. Correct? So it can be, so I can choose any of this letter and make it at the first letter, right? So it's pretty obvious that we can have 4 options. So let's say for accidentally I pick letter A, right? For instance, we don't know what the letters are, but let's say we're gonna pick letter A as the first one. So the second letter has to be different. Remember, the keyword right there is different. So what that means, but that the second letter has to be different from the first one. So for the other option that we're going to have, remember that the first, it should be different from the first letter because they have to be the different letter words. So the second letter can be B, C, or D, correct? This cannot be A because the first one that I pick A, for instance, right? So we only have 3 options left out for the second letters because they have to be different from the first one. So meaning that we no longer have 4 different options. Now we only have 3 different options. So we're going to put them down here as 3 possible way of doing it, right? It doesn't necessarily mean that it's only 3 because the second one has to be less than the first one. So we can't multiply by 4. It only have to decrease the number by 1. It have to be different. So assuming that we pick the second, we don't know what the letter that we pick, but assuming that we pick letter D, okay, just assume that. So let's say the first letter is A, the second letter is D. So meaning that the third letter has to be different from the first 2 letters. So it cannot be A or D. So it can be either B or C. Are we good? B or C, right? So that's pretty obvious for us to put them down, right? Because again, that is have to be different from the first 2 letters. So let's say I pick A and D, so the third letter cannot be one of them. It have to be either B or C. So we have 2 different way of doing it. So that would be 2. Okay, so that would be 2 for this.
I have a question.
Mhm.
I thought you said it can't start with the same letter.
Yes, they couldn't start with the same letter. So let's say the first letter has 4 choices, so we pick A for any letter of that. So the second letter has to be different from the first choice. So we only have 3 options left. So that can be B, C, or D if the first one's picking A, right? So if the first letter picking C, the second letter have to be A, B, or D, correct? We don't know what the letter that we pick for the first one, but we pretty much know it that the first letter has 4 options, 4 choices. The second letter has to be different from the first letter, so they have 3 choices left. And then the third letter has to be different from the first 2 letters, so we're going to have 2 choices left. So choices, let's say we're gonna pick this letter as C, and then what is the last letter? So if we pick A, B, and C, the last options for that would be equal to B because this one has no other choices left. The first 3 choices already been picked from the first 3 letters. So the last letter have to be go with the B in this case, right? It can be any value for that, but this is just one example that we're
So now
going
you
to
multiply
examine them.
all the results.
Well, I haven't finished yet, so we have to. This one we only have 1 option left out. Do we agree? And of course that we need to multiply them because of the multiplication rule that we learned. So that we're gonna multiply those 3 together, right? Multiply 4 times 3 times 2 times 1. So what do you think? So this one is basically 4 factorial. Do we agree? All right. This is basically 4 factorial and equal to 24. Are we good?
Yes.
Because we use up all the numbers for that, and each number, and each one has to be different from the first, and the second has to be, and the third has to be different from the first 2, and the last letter has to be different from the first 3. So we only have 1 choices left. So the total will be 24 combinations. Okay. Similarly, I mean, we're gonna use up all of them, and put it in the M object into M position. So that would be the thing. But this is just a thing. Only exam, I only ask you how to do like 4 factorial or 6 factorial, but we need to understand what the concepts are. It's also really important to know that. All right. So now we're gonna go to another example. I believe this will be a little bit clearer. Let's say we have how many letters. So example, how many way or how many combinations, how many ways can we form a 26 letter word. I mean, we need to use all of that. 26 letter word from English alphabet. I believe this one is more interesting. But it will be impossible to do so. We can see that how many letters for the English alphabet. There's so many of them. There's 26 letters of that, right? And then of course the letter work have to be different. We should put like 24 generally, but I just want to let you know over the concept. On the exam, I should ask you, what is the 4 factorial? So I'm going to give me 24, like 4 times 3 times 2 times 1. Are we good? And so again, that will be different words, and this one is the thing that we have right there. So, all right. So anyhow, this is what the question looks like. And of course, the keyword for that will be the 26 letter word and from the English alphabet. So what is the English alphabet? That we know the English alphabet we have 26 different letters. Correct? So that's obviously going to fill up 26 letters. And apparently that will be 26 factorial, but let me just show you what it is, okay? So the first letter that we have right there, and the second letter that we have right here, and then third ones, and then go blah, blah, blah up to the last one. Right, up to the last one. So apparently that we're going to have, the first one has 26 combinations, right? Because we had 26 options for the first letter, so we can pick 26 letter for that. And the second letter, on the other hand, it has 25 options because it has to be different from first letters. So let's say we pick like the first letters as X. So the second letter will be any numbers, like any A, B, C, D, any alphabet except for X, right? So we have 25 left out. And similarly, the third letter will be, let's say we pick the second one is C. So the third letter have to be all the English alphabet except for X and C because those are already been picked on the
So
first.
you had to.
Yeah, we
Sorry.
have
So
to
you have to
decrease by
keep
one.
going until the whole alphabet is there.
Yeah, it's there.
Decreasing by
So
one by
we're
one by
gonna
one by
do
one.
like everyone for that until we finish the list, which is up to one, right? And then this one, of course, that we're not gonna do it by math. We need to take like 26 times 25 times 24 times 23 times 21, and so on and so forth up to like ones. And apparently this one is equal to 26 factorial. Of course, that we cannot do the calculation for that. It's actually too much to compute, right? So that's pretty much the thing that we have for the the factorial. So now we're gonna go to the next part. The next part will be a little more interesting that we call the combination of permutation. Okay, so what is the permutation in this case? The permutation is actually denoted by P. Why we use P? Because it's representative permutation. It's not probability. Okay, but how do you know if on the question it says like P or probability? So it will be given by N and R. N will be the number of the objects, and R will be the number of position that we're going to put into or that we're going to arrange it. So N and R, the N usually bigger than R for sure, bigger than or equal to. Or another way that we can write them down as we write down a P first, and then after that we're going to put N and R on the bottom. So it's also another way of writing it down. If you ask me what is the most common way, I don't know. We can use either one of these. It'll still be understandable for that. So we have two numbers. So why do we have R in this case? So that will be, what is the definition for that? Let me just do it real quick. So the definitions for the permutations will be a number way of arranging. So now we're not gonna use up like the entire list of N. In this case, we can have like 26 alphabet, and then we have to use up 26 letters, so we need to multiply up to 1. If we have like 4 different letters, A, B, C, D, and then I'm gonna ask us how many weight can we have for different letter words, so we have to use up all of that, all of these letters. But for the factorial, for the permutations, it will be slightly different regarding the thing that we have. So this will be a number of ways of arranging like n objects, but it's not going to be in n position, n objects into r position, right, into a little bit smaller. Okay, so we're not going to use up the entire thing. So the R should be less than or equal to N. Okay, it can be bigger than N for sure. I mean, if we only have like four letters A, B, C, D, we cannot have like we cannot form like 5 different letter words. That make no sense. So in this case, the N should be greater than R or R less than or equal to N. So that would be a legit statement for that. So how can we deal with this question? So the way that we're going to do, I want to give us one example. So this is a previous example that we took. But instead of we going for like 5 different letters, so we're gonna just do it like how many ways can we form like 2 different letter word? Okay, given by like 4 different letters, given by 4 different letters, A, B, C, D. Okay. Okay, so what it means by that is um, we um, going to like see how many way can we have like 4 different letters given by I'm sorry, 2 different letters given by 4 letters that we have. And so this is the N in this case will be equal to 4 because we have 4 letters. So in this case, N equal to 4, N equal to 4. Okay, and now we only want to have 2 different letter words. So this one's R equal to 2. Okay, so that will be a slight difference for that. All right, so how can we deal with that then? So it's basically the same. Instead of we have 4 circles for a previous example, now we only have 2 circles because we want to form 2 different letter words for that. So this one will be the first circle and this one is going to be the second circle. Apparently that the choices that we have right there will be A, B, C, D. I'm going to just change it a little bit since I'm running out of space for that. So we can have A, B, C, or D. Okay. So apparently that the first letter has 4 choices, right? So the first letter has 4 choices. So I'm running out of space. I'm going to put that right there, right? Because it can be either A, B, C, or D. We have 4 choices, correct? So apparently this one is really important. So 4 choices, right? And so the second letter has to be different from the first one. So let's say we pick this one as D, and the second letter has to be different from D. Again, that it has to be equal to A, B, or C. It can be either A, B, or C, correct? So that can be A, B, or C, apparently. I want to change the marker. Okay, so meaning that the second letter has 3 choices left. So that can be either A, B, and C. So that 4 times 3. Does it make sense? So we don't continue on it. Like we don't continue like multiply by 2. We ignore the rest of them. We ignore the second letters, and then I'm sorry, the third and the 4 compared to that example. So let's say the second letter that we picked was C. Okay, so that would be D, C. It can be like A, B, A, C, A, D, or B,
So
C.
we just
Yeah.
take those 2, the first 2 letters, and
And then we
multiply them.
ignore the last of them, right? We ignore the rest of them. So we only take like first 2 would be 4 times 3, so that'd be 12 possible way of doing it. All right, makes sense. We only take the first 2, but we don't multiply into 1 because we only take part of it. We're not going to take all of that. So the thing that we have for the factorial would be the same thing right there. So the factorial is something like that we have here. Okay, so the factorial that we're going to have n, and then we have to use all n. Okay, I'm going to use it all the n terms. So use all n. And apparently that we have to use all of that. Okay, so this is what I call a factorial. Okay, but for the permutations on the other hand, the permutations is I give you the n, and then we're going to use part of it. We're not going to use all of that. So in this case, so we are going to have from 1 to n, right? We're going to get n letters. But in this case, that we're going to use part of it. I want to use a different marker for that. So this one is going to be part of that we're going to use. We're going to use R. Okay, as simple as that. All right. So the thing that we call this guy will be the permutation. Are we good? Yeah. So how can we deal with that for the questions? So let's say I give us the questions like for let's go for another example. Like how many ways can we form two different letter words from English alphabet, right? So I feel like it makes more sense from English alphabet, right? So we're not gonna like use up all 26 letters of the English alphabet. We only use two of them, right? To form two different letter words, and that makes sense in this case where we're gonna have the first ones as the first letter, the first circle, and then the second one will be second circle. So in this case, we're going to have the 26 option for the first one. So it can be any of the letters that we know would be A, B, C, D, E, F, G up to X, Y, Z. So there are 26 letters for that, right? And apparently the second one have to be different from the first one. So we're going to have 25 letters compared to the first one. So that was 25 times 26. And the multiplication for that will be the answers. Are we good? So this one would be the permutations of 26, and we pick 2. Okay, and then of course we're not going to do it by hand. We're going to use a calculator for that. So the calculator have to be done on the virtual calculator. I mean, if you have a good calculator for that, is great. But I strongly recommend you using this calculator so that we never run out of battery during the time that we take the exams, and it's very beneficial as well. So in this situation, we're going to take 26 times 25, and the answer for that is 650. Are we good? 650. Okay, so that'll be the answer for this. So I want to box the answers in the end. Okay. Let's try another example and see how it goes. On the exam, I'm not going to give you something like that. I might just give you like, what is the permutations of, let's pick one example from the book, from the notes. What is the permutations that we have? Yes, the answer should be 26 times 25 times 24 because n equals to 26, and then we only pick 2 different letters for that, so that would be 26 times 25. In your cases, we have to pick 3 letters, so that would be 26 times 25 times 24 because we picked 3 of them. So let's try another example, which is the permutations of 20 pick 3. So that will be from the list of that. You're very welcome. So the permutation of 20 pick 3. So in this situation that we literally notice that there are 20 of them, and then I pick 3 of that. So the first that we need to start with 20, right? And then we multiply by 19, and then we multiply by 18. Correct? That's it. We pick 3 of them.
Wait, why are you doing the second step?
I'm sorry?
Why are you doing the second step right now?
What do you mean by the second step?
No, I mean, why are you doing this right now?
Oh, this is just another example.
Oh, here's another sample. Thank you.
It is just another example from the note. And we just have to deal with the permutation of 20, and then you pick 3. Remember that we don't see the word problem on the exam. You're going to see some of this number, but you just want to understand what it means, right? So this will be the permutations of 20 pick 3 in this case. So that would be 20 times 19 times 18 over here. That we need to multiply 3 of them because there are 3 different letters. So so we're going to take 20 times 19 times 18. So that would be equal to 6,840. Okay, so does it make sense? to us. So what it means by that, so we need to store with the n right there, okay? We have to start with the n, and we have to pick 3 of that. We pick 3 different letters. Right, we pick 3, so we're gonna add up with 3. We need to multiply 3 numbers. If we pick 5, then we have to multiply 5 different numbers, started from the n right there. The n equal to 20. All right, and me try another example. Let's say we're gonna have 20 pick 2. What is the answer for that? So let me just copy and paste, and let's see. Let me go for another from this example, such that I'm gonna pick the permutations of 20 pick 2. Let me just make it a little bigger. Okay, so that one is 20 pick 2. And what is the answer for that then? Anyone? It's just from the question. It's just from the question that we have right there. So this is the 20 pick 3, or we can have 20 pick 2, or I can have 20 pick 5, or 25 pick 6, whatever it is, right? It's just a different question for that. So in this questions that we're going to have like 20 pick 2, and what do you have for the answers? So that would be equal to 20 times 19, correct? And that's it, because we start with 20 and then we pick 2 of them, so that would be end up with a 19. So the 20 times 19 will be, yeah, because I use 3 on the bracket. So the first number is n, and the second number is r. Yeah, we just multiply 2 numbers for that, and we just pick 2 numbers so that can have 20 times 19. I'm sorry, 20. Yeah, we only go down 1. I apologize. So 20 times 19 is 380. Yeah. So remember that the r equal to 3, so we're going to pick 2. So in this case, you can literally check that the n equal to 26, and then the r equal to 2. The second number will be the r. I think I did. So the second number will be the r, the n equal to 4, and r equal to 2. So the r always less than equal to n. It cannot get bigger than that. So in this case, r equal to 2, so we're going to pick 2. Okay, because r equal to 2, apparently. And so this is the thing that we might want to pay a little attention to. And in this case, that apparently that we're going to pick 2 because the r equal to 2 in this case. Right, because the r equal to 2 right there. Are we good? Are we good for that? So let me just take another example and see how it goes. For instance, I would like to.
So I have a question, Professor, before you do that. So the numbers on the parentheses, right? The number that's to the right of the parentheses is the number of letters.
The letter we pick
okay.
from the group, a group of 20 or a group of 40 or so on and so forth. Okay, so let's take another example. I think I use up all of that. So 12 pick 3. No, we don't have that. So let's say we pick 18 pick 2. Same thing, right? 18. Let's say I pick 5. What do we have for that example? So that would be equal to 18 times. How many numbers do we have to multiply? We need to multiply
18 times 17 times 16.
16 times 15 times 14. That's it, right? We're going to stop right there because we multiply 1, 2, 3, 4, 5. Each time that we multiply, we have to decrease the number by 1. So for that example, so we're going to take 18 times 17 times 16 times 15 times 14. So the answer for that is 1028,160. Okay, so that would be the final answer for that. Are we good? So this one, we're going to have like 18 letters. Now we start from 18, and then we pick 5 of them. Why do we have to pick 5? Because the questions ask us right there. So this one is R, and this one is N. Are we good? So in that example, I'm going to pick 5 different letters for that. So pick 5 of them. All right, so far so good for that. And now we're going to go to the next part of it. we're gonna go to the next part of it, so that we call the um, combination. So the combinations will be the thing that we pay most attention to, because that's one that's gonna be really important. So the combinations denoted by C, okay, and then N and R. So N pick R. So and then why people use C, the letter C, to denote for the combination, because it started from the C letters right there. So we're gonna use C a lot. Or sometimes that we can use like C and then N, and then we pick R. So I have like N group of the objects, and then I only pick part of it. Okay, so N pick R. And sometimes on the notes that you might see some term like that. So they break down the N first, and then later on going to be the R. Either way, it's going to be working out for that problem. And sometimes there's a lot of code they might use this parenthesis and pick, or this one is more common in like more advanced statistics. Then we have to start statistics from scratch. And this one is it's not going to be using in this class, but this is somehow we call it binomial coefficient. It's really important concept when we're dealing with the Pascal triangle. It's really interesting for that as well. But anyhow, the combinations again that will be, what is the definition for that? So the definition for that will be a number of way of arranging. So in this case, it's not going to be like a distinguishable object, right? It's not going to be this thing. So we're going to arranging the indistinguishable objects. So what's the difference between them? Indistinguishable object. Okay, indistinguishable objects into and position. So what would the difference between the permutations and combinations? So that would be the big deal that we need to consider. Okay, so for the combinations that we do not count the order of the objects. So in this case, that we can really think of that ones will be and indistinguishable objects. So this one might be the same object. So we do not really count the order for that. So the thing that we need to pay attention for the combination is that the order doesn't matter. Okay, so we can use so the order for the objects that we going to count does not matter, does not affect us. The only thing that we really pay attention will be the position of the R, and this is how we're going to deal with that. So the combination for that will be pretty straightforward. So let's say we toss a coin. We toss a coin. We toss a coin like 4 times, for instance, right? And then we want to know like how many ways, how many combinations can we have, or how many ways we can do that as well. Can we obtain 2 heads? So those are somewhat important that we think of this problem as the number of heads that we collect them. Okay, so so if we toss a coin, that we can either result in either result like tail or head. In this questions, we do not have another part of it. So apparently that when we toss a coin, so we call it this is a coin, and I don't really have a coin with me, so we can try them out. And the coin that we're going to have the options either head or tail. Okay, so the head that we call H, and then the tail that we call T. Okay, so this is what we call H, and the tail that we call the T. Okay, so it's really important. So so when we toss a coin, so we're going to have like 4 different coins for that, right? So this one gonna be like 1, 2, 3, and 4. Okay, so of course they have to have like 4 different coins, 4 times. So we can. This is the first time that we toss, right? So this one is the first time that we tossed, and this one the second times, and the third times, and then the 4th time. So we can literally check them. So I want to have two heads. I'm only interested in getting two heads. I'm not gonna get like the combination of three heads or one head or four tails, right? So I basically going to consider like two heads only for the combination that we pick. In this situations that we're going to have like head, head, tail, tail, right? For instance, so this is one combination that we're going to form, correct? And so that's pretty straightforward that we can have like head, head, tail, tail. So meaning that the first two are head and then the last two will be the tail, correct? Or I can have like head, tail, uh, head, tail. I would say that that was pretty obvious, correct? Head, tail, head, tail. So it can be either, you know, the first and then the third position that we're going to have this, right? Okay, so the next part of it that I can either have the first one is head, and then the second one is tail, and then the third one is tail, and then the last one is head, right? So that would be head, tail, tail, head. And I can also have like the first one is no, the first one is head doesn't work. Um, so the first two will be the head, and then the first, the third, and then the first, and then the last. And similarly, I can have the tail, and then after that there'll be the head, head, and tail. Okay, so this one will be a different combination. So we only look at the position of the tail or the head that we're going to count them. So that's really important. So after that, I can also have like head, tail, head, tail, head. I would say it will be a different combination for that. So, and then finally, I can have a tail, tail, head, head. So that will be the first two. The last two head that we're going to have 10 on the list. So the total combination that we're going to have will be six way of doing it with six combinations. So we cannot get more combination beyond that. So the only possible that we have will be the first two will be the head, or the first, the third, the first and the last, the second, the third, the second, the last, and then the third and the fourth. Okay, so those are a total of six combination that we can obtain from the list. Are we good? So we can rearrange them. The only possible way that we can check the answers, we're going to list all the possible cases, but there were some situations that would be impossible to do so. Like a lot of situations that we're not going to spend like maybe 20 years looking for like how many ways can we choose 5 different letters from 18 combination from 18 from a group of 18 words. So that's going to be really, really challenging for us to deal with, right? But if the situation is not really complicated, then we're going to count them, like how many ways of getting two heads out of the coin being flipped 4 times. So in this case, that we're going to have 6 ways of doing it, right? So this one, we're going to call this is the combinations of 4 and then pick 2. Why 4 and then we pick 2? Because because we're going to flip the coin 4 times and then we're going to pick 2 heads. So in this scenario that we can identify the and immediately. So the and in this case will be 4, right? The and always be the big number. And then the R in this questions will be 2 heads, so the R equal to 2. So always write down the N first when you see a problem like that. So what that means is that the N always less than equal to R. I'm sorry, the R always less than equal to N. This cannot be like more than N in this scenario. So let's say we flip a coin 4 times. How many ways can we have 5 heads? So that would be impossible to do so, right? And so the R should be less than equal to N. So I believe that will be pretty straightforward. It's pretty important to do so. Okay. So I want to just box that part and make sure that we understand what we have right there. Okay, so how can we do the math in this case? So remember, the order doesn't matter. What that means by the order doesn't matter because the order of the object, it doesn't really matter if we count like the first hat or second hat. So the order of the object that we can see on the list does not matter. So let's say the first and then the third hat. Do we care if the first one will be the hat or the third one will be the hat first? Who's gonna go first? Of course, when you flip the coin 4 times, the first flip have to be the hat, and then the third flip have to be the hat too. So that would be hat, tail, hat, hat. I'm sorry, hat, tail, hat, tail. So we're gonna get 2 hat in this case. So the order of the first and third hats doesn't matter. The only thing that we're interested will be the order or the precision of that. Okay. However, when we look at the permutation that we have earlier, so let's say we only had like 2 letters, right? So let's say we have like 5 different letters, like 4 different letters for that. So that would be A, B, C, D, for instance. Okay, so this is how we're going to check the answers and list all of the cases, right? So let me just call this one as A, and this one as B, and this one as C, and this one as D, for instance, right? So I can have like AB, I can have like AC. So this is how I'm gonna list them. It's pretty similar to like the way that we listing like 2 hats, AC, like the first 2, and then the first, the third, and then we're gonna go with the AD, right? And then we keep going there. We can have the BC, right? The second, the third, and then BD, and then CD, right? However, so we can think of it like, so there are only 6 possible way of doing it, but why there are 12 of them? Because the AB will be different from BA, and AC will be different from CA. Like AD will be different from DA, and BC will be different from CB. BD will be different from DB, and CD will be different from DC. So it turns out that there are 6 combinations because the order of the A and B will be different because we have 4 different letters. In this scenario that we have earlier, that I only flip a coin 4 times, the number the number of hat will be the same, right? So the hat will be the same hat that we have for the first 4 list that we have right there. So in this scenario, when we do the math, that we're going to take what? That we're going to take 4 times 3. It's basically the same thing as we do with the permutations, except for the fact that we need to divide it by what? We need to divide it by 2 factorial. Okay, we do not count the order of the object, so we have to divide it by 2 factorial. Okay, so in this case, I'm going to divide it by 2 factorial. Again, that we're going to start it from 4 as well, obviously, because we have 4 times. Why you choose 3? No, I did not choose 3. It's just the number of times that we multiply. Remember, it's pretty similar to the permutations. Like this, why this is 20 and then have to go down by 1. Y is 19, Y is 18, because coming from the factorial combinations. So first we look at the factorial thing that we need to, when you multiply a number, that we have to decrease by 1, right? Similarly, so that'd be 4 times 3 times 2 times 1. In this scenario, it's going to be the same thing, like 26 times 25 times 24. And for that scenario, you're going to get 18 times 17 times 16 times 15 times 14. And then similarly for that, so that'd be 4 times 3. So why we only multiply up to 3, but why not multiply by 2? Because we have to, whenever we multiply a number, we have to decrease the number by 1. Okay, so I feel like that's pretty important. So in this case, I'm gonna pick 2 of them, right? Pick 2. Are we good? Does it make sense? All right. Okay, so but we do not count the order of the number of hats. So it's different compared to the permutation where we have to count the order for that. So apparently that we're going to have like 4 times 3 equal to 12. And then we know the fact that 2 factorial is also equal to 2. So that'll be 12 over 2. That would be equal to 6 way of doing it. Okay, so 6 way of doing that. So equal to 6 combinations. Okay, so this will be 6. This is how we're going to check this, right? But this is how we're going to compute it. And this is what we have to pay attention to that on the practice problem. So let me just go to the practice problem real quick and let's see what it is. Okay, so let's say I'm going to start with the combinations of 12 pick 3. Okay, let's go for it. Right, and then let's start with the combinations of 12 pick 3. So what should we do for that? 12 pick 3. So we're gonna take pretty much like the same thing with the permutations. It's basically the same as permutation of n pick r, and then we divide it by r factorial, same like that.
Times 11.
I'm sorry. Would it be what? Would it be like 12, right? So we start from 12. How many numbers do we have to pick? So we pick 3 of them, correct? So we pick 3 of them. So 12 times 11, right? Times 10. So we stop right there because we pick 3 numbers, like 12 times 11 times 10. But we do not count the order of the object. We just stop right there. So this will be the permutation. This is not a combination. Okay, so when it comes to the combinations that we have to divide it by r factorial in this case, so in this case that would be 3 factorial, right? So we have to divide it by 3 factorial. Okay, so it's really important that 3 factorial is not equal to 3. So 3 factorial is 3 times 2 times 1, so that would be equal to 6. So let me just put it right there. So 3 factorial will be 3 times 2 times 1. So the answer for that equal to 6. So it should be different. However, 12 times 11 times 10. So we can have this one 12 times 11 times 10 over 6. And the answer for that equal to 220. Okay. So this one will be a thing that we're going to put in there on it. And so, and then we divide it by 6 in the bottom. And apparently that the answer for that is 220. Okay, so how can I come with that? So first we need to store n, right? N equal to 12. And then we pick 3, right? We pick 3 of them. So this one we pick 3. Correct? So we need to multiply 1, 2, and 3. So 12 times 11 times 10. So we're going to pick 3 of that. And then we also have to divide it by 3 factorial. And so that would be the thing. So combinations will be pretty complicated when I look for the word for that. So let's try another example and see how it goes. For instance, I want you to take like the combination of 1,000 pick 2 for that example. So let's go for it. The combinations of 1,000, and then I pick 2 of them, right? So, and of course that we're going to start with 1,000 times 999, not times 2, right? We need to multiply. So each number that we multiply has to be decreased by 1. So we pick 2 of them. So the one we're going to get 1,000 way of doing it, and the second we have 999 way of doing it. But remember, the order of objects that we're going to have should not be counted. So we don't count the order for that. Meaning that we divide it by 2 factorial, which is 2. Okay. And apparently that we can get this done on a calculator, which is 1,000.
How you know that you divided by 2?
Because we have r equal to 2.
Okay.
If we have this one equal to 5, then we have to divide it by 5 factorial. And then we multiply 1, 2, 3, 4, 5. Make sense? Over 2. And then we're going to get this one equal to 4,999,500. Okay? So in other words, that we're going to have this one is 4,995,000. Are we good? If I give you a certain question like that on the exam, would you be able to do it? So remember that in this thing that we're gonna, why do we have only multiply by 2 like 99? Because we picked 2 of those, right? We picked 2. So we gotta be really, really important. We gotta be careful for that. Okay, so similarly, but let's say we're gonna have another example. Let's say we have like last one, like 88 pick 86. So let's say I flip a coin 88 times. I want to get 86 hat. What should we do? So this one should be a slightly different compared to the problem that we have, right? So let me just repeat that again. If we only have like 88 and then we pick 86, meaning that I want to have like 86 hat, but if we're not going to multiply like 86 times, like 88 times 87 times 86 times 85 times 84, and so all the way forever. So in other words, if we want to get to 86 hat, meaning that we're going to get 2 tau out of 88 flip, right? It's going to be the same as the combinations of 88 hat, and then we pick 2 tau. Okay, so I'm sorry, it's basically the same as the combination of 88 flip, and then we got 2 tau. Remember, the way that we can arrange 86 hat will be the same as the way that we can arrange 2 tau. So what should we do for that example? So we're going to take 88 minus 86, and we got 2 right there. So for that example, and then we're going to start with the first one will be 88 and times 87. Remember that we only multiply 2 number. We no longer multiply like all of that up to 86 number. So that's going to be crazy. Okay, we're going to subtract them first and reduce to 88 pick 2. So that'll be 88 times 87 over 2 factorial. So that's going to be the same as 88 pick 2. Okay, so for that example, that we're going to get the answers correctly for that. 88 times 87 over 2. And the answer for that is 3828. Okay, similarly, when we see like 2 number, they're really big for that, we just subtract them so that I can see, you can get the final answers correctly. All right, I feel like it's a little bit too much for this. Any concerns? Why 87? Because each time that we multiply a number, you have to decrease the number by 1. Yeah, so that's really important. So we start from 88, then we have to, so we pick 2 of them, right? So 88 pick 86 going to be the same as 88 pick 2. And then meaning that we're going to multiply them like 1 number smaller. Okay, and then we divide it by 2 factorial. All right, so I feel like that's going to be a little bit too much for us. And then let's just take attendance and then we call it a day. And then we just box the answers before we go. All right, so let's just box the answers before we go.
You got a homework about this or no?
There's no homework for that here. This will be on the exam questions. All right, so after the exam, no homework, and let's take attendance, and we can leave after I call your names, that you don't have to worry about that. And Shayla is here? Shayla?
I'm here.
Fantastic. And Venice?
Yeah, I'm here.
Very good. Permandar is Permandar is here? Wiener is here. I saw your nexus. Ulysses is here. Ulysses here.
When will you post the exams?
I'm sorry.
When would you post the scores for the exams?
I would be posting like a week after the exam. So we took the exam on Wednesday. So the exam grade will be posting on this Wednesday. Unless that you want to know the grade, you can email me. I can grade your exam quickly, because I need to put down like specific score on the exam. So it might take me longer. And then sometimes we take a photos, I need to download it and check the answers for each question. So it took me around 15 minutes for each person to get it graded. Okay, so it might take a little bit long for me to do so, but I will basically get back to all of your exams grades on Wednesday. Okay, is that fair? All right, so let's get, yeah. Ulysses?
I'm sorry, was that exam considered the midterm, or?
There will be 2 midterm for that. Yeah, I always consider that as the midterm grade, but it doesn't matter for that. As long as we can continue working well on the second exam and the final exam. So the third exam will be 20% of the class average. Okay, so that reach 1% for that.
So there's no quote unquote midterm.
There's no term that we call midterm generally. It's just called exam one. And when I post your midterm grade in Blackboard, I will use that exam score as well. That doesn't make any sense. Some people got like 60 on the midterm. They still end up getting an A minus at the end of the semester because they did well on the second exam and the final exam, and then they did perfectly okay on the quizzes and homework. So the third exam is just something that we have to score. Some people got 95 in the third exam, maybe 98, but they still end up getting a job out of the class because the second exam is going to be a lot harder. And it just depends on how we look at it. Okay, Ulysses,
Thank you.
you're very welcome. Afraid, sir? Afraid? Okay. Diego is here. Jose is here. Adama is here.
Yeah.
Fantastic. Yes, Bailey.
I'm here.
Eric.
I'm here, Professor.
All right, got you. Arlene is here. Arlene.
Here.
Very good. Emily. Katrina is here. Yeah. So again, that for those of you who want to know the grade, please email me, or you're gonna see me after class for today on Zoom, right after class at 3:30, and I will basically grade your exam first. Adu is here. Perfect. Virgin is here. Virgin.
Yes, I'm here, Professor.
Very good. Near is here. Ricard is
Yeah,
here.
here.
Joe is here. Kimberly is here, right? Kimberly just told me that she has an appointment for that. Janet is here.
Here.
Stephen. Okay, Stephen Perez. All right. And again, that Jason's is here. Selena is here. And Robert's here. Amber is here. Amber.
Here.
Very good. Melinda is here. And Jodali is here. Brian's here. Oliver is here.
Here.
Absolutely mark your present for that. Yeah, because I saw the nick and right there. All right, so you guys are going to have a great day. And again, that I will basically post a grade in Blackboard on Wednesday. So just give me some time because it took me a little while to put the solution for each questions and put that point for each question. I want to be more specific so that you can have the grade as clear as possible. Take care. Have a great day.